In last video, we have discussed a lot about the dip and the strike. Basically, dip is the inclination of the beds in reference to the horizontal plane. Suppose this is the horizontal plane. Horizontal plane. Okay. Here beds are dipping. Beds are dipping. All are beds. Suppose these are beds. Beds 1, bed 2, bed 3, bed 4, this board. This angle, this is the horizontal plane and this is the inclination of the beds. In that direction, beds are inclined. Okay, so this angle, suppose this is theta, this angle is the dip. Okay, now come to the point of strike. Okay, strike always lies perpendicular to the depth. Rather, strike is the intersecting point. If you identify the strike, then you have to identify the intersecting point of the bedding plane with the horizontal plane. Suppose this zone is the horizontal plane. Those are the intersecting point. The intersecting point of horizontal plane and the inclination of the, then you have to connect this point and you can easily get the strike line. Okay, strike line. So there is a relation between the strike and dip. Suppose this is the horizontal plane. Suppose this is the horizontal plane. This is the horizontal plane. Okay. And here particular beds are dipping or inclined. This is bed 1, this is bed 2, this is bed 3, this is bed 4, so on. All are dipping. And those beds are inclined in that direction. This is the direction of inclination of bed. Okay, inclination of rock bed. Okay, beds. The angle between the horizontal plane and the inclination of rock bed, that is the theta. This is the dip. This angle is the dip. What is the strike? Strike is the intersecting point in between the bedding plane and the horizontal plane. This is the horizontal plane. This is the horizontal plane. This one is the horizontal plane. And these points are the intersecting point. These are the intersecting point of horizontal plane and bedding plane. Horizontal plane and bedding plane. So you have to connect those points. We are connecting those points, and this line is strike. This line is called the strike line. Similarly, this strike, if you draw a parallel line of that strike line, then you can identify a strike line here too. So horizontal dip is the inclination of the bed. Those are the rock bed. Those are the layers of rock strata. It's called the rock bed. These rock beds are inclined in that direction. Okay, this rectangular shape plane is the horizontal plane. This theta angle, the inclination of rock bed with in reference to the horizontal plane, is known as dip. Okay, for the strike, first we have to identify the intersecting point. Intersecting point in between the horizontal plane. This is the horizontal plane. This is the horizontal plane and the intersecting of the bedding plane. This is the bedding plane intersect with the horizontal plane in that point. If you connect those points, you can get a straight line. This straight line is known as strike. So strike is the intersecting point of the bedding plane and horizontal plane. What is strike? Strike is a direction of line. Okay, so we have to get, now I think you are clear enough regarding the concept of dip and strike. Strike is a straight line. Strike is a line. Strike is a line. Strike is a line. Okay, and it's a you have to identify the strike line to identify after the identification of intersecting point of intersecting zone of bedding plane and horizontal plane. Okay, horizontal plane. Okay, so it's we are from that lecture you, I think the idea regarding the horizontal plane and regarding the strike line, regarding the deep, I think you are clear enough, and you can get a real picture about the diff and strike. And always diff and strike are perpendicular to the each other. Perpendicular to the each other. Okay. Perpendicular to the each other. Diff and strike. Okay. Okay. Now come to the point of strike line. And for the identification of diff, we have to take the help of strike or strike line. Strike, always we have to identify the dip in reference to the strike and strike line. Okay. From this picture, this is a this is the horizon, this is the bedding plane. These are the bedding plane. Suppose this is the horizontal plane. This is the horizontal plane. Suppose this zone is the horizontal plane. Those are the beds. Those are the beds. Beds are inclined in that angle. Okay. That angle is theta. That angle is the D. Okay. What is the strike? Where is the strike line here? All the beds intersecting and join that line. You can get the strike. Okay. Suppose this line is parallel to that line. Strike. So, diff, this is the diff, and that line is strike. So this angle is 90 degree. Therefore, strike and diff always perpendicular to the each other. Suppose this is the diff, this is the inclination of rock bed, and this is the horizontal plane. Okay, this is the horizontal plane. This is the inclined rock bed. Okay, so therefore that angle is the diff, and strike, you can identify the strike. These are the intersecting point of the bedding plane with the horizontal plane, and this is the diff, and that is the strike line. Strike line and diff always lies perpendicular or lies 90 degree or perpendicular to the each other. Okay. Now with the help of the diff, with the help of the strike line, we have to identify the diff. Before going to the details, I would like to mention one thing. In earlier class in same one, I have told you what is the slope. Suppose your friend is standing here and another friend B is standing here. Suppose A is standing above the 128 meter above the sea level, and B is standing 125 meter above the sea level. Okay, and A start walking to reach B, and the distance in between AB is suppose 20 kilometers. So what is the angle in between A and B? Okay, you can easily identify that this horizontal distance is 20 kilometer between the A and B, and height of A is 120 meter, height of B is 125 meter. The height difference, the horizontal difference in between A and B is 3 meters. Suppose A is standing 3 meter above the 3 meter 3 meter higher than the B. So this is the angle, this is the gradient in between A and B. In technically we can call this horizontal equivalent. This is the horizontal equivalent. This is vertical invert and vertical interval. In previous class I have told you, and this is the A, this is the B, and it's the C. According to the Pythagorean trigonometry, you can get tan inverse, and you can tan theta, you can get the value of tan theta, and with the help of vertical interval and horizontal interval you can easily identify the slope or the gradient in between the A and B. This is the basic principle to identify any gradient, any slope or any angle, any dip and any inclination. Basic formula is the horizontal equivalent, it is the horizontal distance, and this is the differences of height, that is the vertical interval. Then tan theta, tan inverse theta is equal to vertical interval divided by horizontal equivalent. This is the basic formula for identify any kind of slope. So go for the details. We have to this is a geological map, okay, and with the help of the strike line we can identify the dip, because dip and strike are perpendicular to each other. In geological map we always plot all these things in reference to a particular section line. We draw all these things in reference to the section line. Suppose this is the section line, this is A and B. So you have to draw you have to identify the strike point. Okay, the easiest way to identify the strike point, go through a contour and go through the bedding plane. Upper part of the bedding plane is known as upper boundary of the bedding plane. Lower part of the bed is known as lower boundary of bedding plane. Suppose you have to choose one. If you identify the upper boundary, so you have to follow the upper boundary. If you select lower boundary of any bed, then you have to follow the lower boundary. If any contour of a same contour cut same boundary in it twice, you have to identify that point. Suppose this is the 300 contour, 300 feet contour, because there is a scale in feet. So we have to identify that point and we connect that point. Okay, cut that bedding plane, connect that plane. The value of the contour is 300 meter. That is the value of strike line is 300 feet. So the value of strike line is 300 feet. Okay, then you have to go for same, you have to think, you have to identify the same bedding plane. If you go through the lower bedding plane, then you have to confine within the lower bedding plane and go for the another contour which intersect that bedding plane. Suppose this is a contour. At least you have to identify one point, and through the help of set square, draw a parallel line to that line and put the value of that strike line. Suppose the value of contour is 400 feet. So the value of strike line is 400 feet. Okay, this is the basic principle to identify the strike line. With the help of strike line, we can identify the dip. Dip and strike are very very closely related. Okay, then suppose you have to take this distance with the help of compass or scale. Suppose I have told you that geological maps have two parts, interior part and the outer part. So at initial stage you have to draw the profile line. Suppose take the distance of A you have to take the distance of A and B, and take a horizontal scale, sorry, take a vertical scale, and you go through this contour value and draw the profile. It's very simple. Suppose profile is that kind. Okay, draw a profile. After drawing a profile, then this direction of AB is that kind of direction. Okay, after drawing this kind of profile, this is the profile. First thing is draw the profile lines along the section line and identify the landscape. Identify the landscape. Suppose it's an undulating landscape, it may be the unique island landscape. First thing is that draw the profile along the section line and identify the landscape. Second thing is that identify the dip. How to identify the dip? With the help of straight line. Without straight line, no one can identify the dip. So with the help of straight line, you can identify the dip. Suppose this section line is inclined in reality, but when we are drawing, we are taking that distance and put it horizontally. Therefore, suppose this is the value of straight line is 303 feet, it is 400 feet. Therefore, this distance is the distance of the section line. We can draw it in same base, but for the neat and clean presentation, we can draw the another line. If someone try to draw all these things in the baseline, but they can pursue it. Suppose you can, with the help of compass, you can take this point and that point. Okay, with the help of compass, accuracy is very important in geological map. And this is the value of 300 feet. This is the value of 400 feet. So this is 300 feet and this is 400 feet. In a geological map, there is a scale of statement scale. There is a scale that 1 inch is equal to 1000 feet. According to the scale, suppose this is 300 feet and this point is 400 feet. Both are lying in the same horizon, but it's not the true fact, because 400 is higher than 300. So according to the map scale, you have to plot this distance. Okay, and draw that angle. Here I would like to mention that suppose someone is thinking that taking that distance in that way, this is 300 suppose and 400. Someone is thinking that this is the 400 point, so 300 point will be below than that line, and he or she can draw that line in that way. Both are same. Suppose this line is perfectly parallel to the line, that line. So you can take that linear distance. This is the horizontal equivalent, and place the horizontal equivalent is here. Put the value here and here, and draw the height according to the scale, and you can easily get the D. This is theta. With the help of protractor, you can also measure it. You know that is this distance. This is a difference between the 400 and 300 is 100 meter, and horizontal equivalent is not known to you. If you measure this linear distance according to that scale, you can get the distance. Okay, then with the help of that distance, you can calculate the tan theta value. You can identify the angular value or the angle of the D. Otherwise, you can measure it. You can put the zero line in here. This is zero line. This is zero line, and this is zero line. Suppose this is zero line, and you can identify the dip of the angle. Okay, dip of the angle with the help of compass. This will be the zero line. Okay, this is the horizontal plane. In reference to the horizontal plane or straight line, we are drawing all these things. Okay, so easily you can get that direction. Suppose here the direction will be, if you pour the water, then water will follow the surface elevation. Okay, always water moves from the higher height to the or higher elevation to the lower elevation. So the deep direction will be that way. Okay, this is the section line direction. Here the direction is B to A. Suppose here the direction is B to A. Direction is that kind. Okay, it's perfectly matching with the drawing. Then you have to fold this map, and this is an imaginary drawing, that's why it's not perfectly matched. It's took the and in it if after plotting the profile line, you have to identify the profile in that way, and took a set square and scale, or two set square. With the help of the set square and scale, with the help of set square and scale, you can easily plot the geological map. You can easily plot the geological map. And after plotting, you have to go through this thing. You have to, student have to go through this line, because all these things along the section line. So along the section line, first you have to put the symbol for that bed, then you have to put the symbol for second one, then you have to put the symbol for third one, then fourth one. This is an imaginary drawing, not the perfectly drawn. Okay, then in that way, after identification of angle, you can easily draw all these things. Okay, here from first thing, and after preparation, you have to draw succession of rock beds. And it's not total copy of the succession of rock beds of geological map. You have to follow the section line. Which page comes in the section lines, a student have to follow that sequence from upper to, that is upper to lower. Upper are the newer bed, and beneath bed or underlying bed there are lower bed. Okay, this is the basic thing of geological map. Okay, here for the theoretical part of geological map, I want to say one thing that that the true dip and apparent dip, and next thing is the line of unconformity. This map is very simple. Okay, and another thing is that uh, um, if the contour lines runs parallel to the beds, here the beds and contour line intersect. Okay, so we are getting strike line with the help of that intersecting point, and after drawing the section line, we can get the dip or dip direction. Suppose all the beds and contour line runs parallel. Okay, never intersect to each other. In that case, suppose this map is not that kind of map. Suppose all are running parallels, contour are running parallels to the bed. So that cases, all the beds are horizontal bed. Okay, dip is 0 degree. I told you in last class that maximum dip varies from 0 degree to 90 degree. Either bed is perpendicular, that is 90 degrees. Suppose beds are perpendicular, or beds are lying parallel to the each other, that is 0 degree. If contours and the beds runs parallel, never intersect to each others, that is the beds are horizontal, that is the horizontal, and the dip is 0 degree. 0 degree dip means the angles are, beds are horizontal. Now come to the point of another thing. I told you that the geological maps are marine origin, okay, and all the layers are mainly sedimentary. A few layers are the metamorphic rock. Suppose, and tectonic activities are very important in geological map. Suppose beds are deposited by the riverine and marine erosion. Suppose these beds deposited, then these beds deposited by the riverine erosion, then that one, so on. And after the deposition of this bed, the earth, there are changes in earth tectonic activities. Then the pattern of deposition has changed. Then another layer of deposition started, but not horizontally. This bed is perfectly horizontal, this bed is perfectly horizontal, this bed is perfectly horizontal, or the deep direction of that bed is matched to that bed, and the deep direction of that bed or the angle of inclination of this bed is perfectly matched to those bed. Now after the changes of the earth tectonic activities or the some volcanoes and all these things, changes in earth tectonic activities, after that activities the deposition started, but rocks and sedimentary layer start to deposit it in that way. Suppose this layer and deposition of that layer, then this layer, then that layer, so on. So this zone, this zone is the zone of changes. This line or this surface area is a zone of changes. This surface area is demarcated for the changes. That kind of changes is known as line of unconformity. So those are the uniform, those zones are the very similar to each other, and that zone is also similar to each other, but there is a remarkable variation, remarkable changes in between that zone and this zone, and this is the surface area of that two types of deposition or two types of rock beds. This changing zone or this surface zone is known as line of unconformity. How do you identify the line of unconformity? Conformity means similarity. This bed, the dip of this bed is drastically or remarkably different from that kind of bed. Therefore, the tectonic activities of that era and during those deposition are remarkably differ from that era. Okay, so how do you identify the differences? Okay, normally the conformity point or unconformity point identify the triple point junction. Suppose this is the bed 1 and this is bed 2. This is bed 2. You identify that point. Three beds are there. Bed X, bed I, and bed lower, bed plus. This, suppose this one is the junction of three bed. Okay, this bed and this is another bed and underlying bed. So you have to identify the triple point junction. After the identification of triple point junction, you can easily identify the line of unconformity or the changes of the diff. Okay. Here I would like to mention that if the geological formation of a particular area maintain a uniformity, just like a era of fashion on the world of fashion. Okay, suppose this is a marine deposit and beds are deposited in that way in in early tertiary era, but in Pleistocene era deposition was that kind, and there is lots of changes in tectonic activities after the Bhuj, suppose Bhuj earthquake, and deposition start in that way, suppose, and this era and this type of formation and deposition is different from intermediate stage, and this is also different from this one and this one. So you have to identify the changing point or changing zone. Identification of changing zone depend on the triple junction point of the rock bed. This is rock bed A, this is rock bed B, this is rock bed C. So A is a junction point of A, B and C. Suppose this is X and Y. This point is the junction point of X, Y and C. So here, this is, suppose this is M. So this layer is M layer. This is the junction point of A, B and M. So through the triple junction point, all can identify the changing point or the line of unconformity. What is unconformity? Unconformity is the surface of of contact between between two group of formation. দুটো যুগের দু রকমের ফরমেশনের মাঝামাঝি আসে লাইন অফ আনকনফর্মিটি. The surface or contact. First, we have to identify the unconformity point through the triple point junction. To connect the all triple point junction, we can get the surface. That surface is a contact between the two different type of formation, and that surface is called line of unconformity. Okay. Line of unconformity is a surface or the contact zone. It's a contact zone. Suppose that kind of formation and this kind of formation. This is the contact zone in between that one and this one. It's a contact zone or surface zone in between the two rock unit. It's a rock unit A, it is rock unit B. Suppose within the zone of a particular unconformity, all the rock beds, all the depth are uniform, and the depth of the rock bed within B zone, the depth angle of the depth is uniform. Okay, how we will identify the line of unconformity? Suppose this is a geological map. Okay, and you have to go through the geological map, and suppose this is the triple point. Suppose this one and this one. This is the triple point junction. Okay, so this is the line of points of unconformity to connect those lines. Normally, unconformity line symbol is that kind of symbol in a red color conventionally. Through that kind of line, student easily can identify the line of unconformity. The formation of the geological era, the formation of rock beds within that part is different from those one. So therefore the beds, angles, strike, all these are different from that part to this one. Okay, so for that kind of map we have to draw more strike line, because within the same geological formation era depict same kind of depth. But if there is an unconformity line in between those two different formations, so for depth of the upper part is remarkably different from the lower part. So you have to go for lots of strike line. Okay, this is the basic theme of line of unconformity. What is line of conformity? Line of unconformity is the surface or the contact zone between the two rock units. Okay, this is rock unit. Suppose this is rock unit 1, this is rock unit 2. Okay, this is the what the line of unconformity is the surface or the contact zone between two rock unit. Actually, line of unconformity showing the geological gap. Okay, it's showing the geological gap. It's showing the break in the geological record. Break or gap in geological record. Okay, line of unconformity normally or conventionally shows through the red line with that kind of line. Okay, so we can easily plot the line of unconformity in geological map. Okay, and method is same. Okay, suppose this is the geological map, and for suppose this is the x and y, this is the section line. For that segment we have to think all these things along the section line. We have to identify, suppose this is the lower series and this is the section line. So draw the strike line. Value of the strike line depends on the contour value. Contour value is 200 feet. Then within the same dipping plane, this is another cut point. So this is the value of this contour is 300. If you pour water, then water goes for higher elevation to lower elevation. So get that way you can identify easily. This is the point A and B with the this is X and Y, and with the help of compass take this distance. Suppose this is 300 and this is 200, and with the help of that scale you have to identify and easily draw this angle. Suppose you can easily get the deep or the rock bit of the lower series and go for the upper series. Upper series means the above the line of unconformity. But here looks, all the bits are runs parallel to the contour, right? That means it's a horizontal blade. So therefore when you draw all these things in paper, so bits run parallel to the suppose you are drawing that kind of map. Suppose this is the landscape. Okay, suppose this is the landscape. Suppose with the help of, this is imaginary, not real. Here this is the line of unconformity. Okay, then you can get two bits. Suppose you can get two bit. Okay, after that all are parallels, then unconformity lines lies in that way, and then you can two bits all are parallel. Okay, and maybe this is parallel, upper series is parallel, but in other cases upper series may be parallel, maybe certain diff. Okay, that's way. And third thing is true diff and apparent diff. What is true diff and apparent diff? Okay, true diff, apparent diff. Okay, next class we will discuss true diff and